Here's the first 7 terms of a quadratic sequence. Finds the nth term. So the nth term is going to be n times, so n something squared, maybe a number in front of it, get to this sequence. Now, there are 2 ways to do it. I'm going to do the easier way and I'm going to do the harder way first. And the easier way doesn't always work, it's just good to know. Because it's a quadratic sequence, it's going to have something to do with squared numbers. So I'm going to write my squared numbers, which are 2, is a 1, and then 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Now luckily you can notice a pattern, and because this is the foundation higher paper crossover, you'll actually notice that these numbers are always 2 more than the n squared. So these are my squared numbers, which always represents as n squared, and I'm adding 2 to get this one. That's your easy way. Right, I'll do the harder way at the end of the video just in case you don't know it. The nth term of a different sequence is 2n squared plus 5. Work out the 6th term. Now the n denotes your position, so it's actually going to be 2 times 6 squared plus 5. We use the rules of bid maths, so we've got to do 6 squared first. 6 times 6 is 36, plus 5, 2. So I've got to times it by 2. 36 times 36 is 60, 72, plus 5, 5, 6, 7 to the answer 77. Now let's go back to this one. Let's work out the harder way. So I'll rub this out. Right. First thing we do is we work out the difference. Okay, difference between 3 and 6 is 3. 6 and 11, 6, 7, 8, 9, 10, 11, which is 5. 11 and 18, 7, which is 9. Okay, now let's switch first level difference. Now 3, 5, 7, 9 is actually a nth term sequence, but we've got to find the second level difference. Okay, which is 2, which is 2, which is 2. So what this means is in my nth term, the number here will always be half of that. Okay, so half of 2 is 1. Okay, so I'm going to write the original sequence out again. 3, 6, 11, 18, 27, 38. Okay. Now, this is always going to be in the form of an squared plus bn plus c. Okay. But we actually know that this an is actually going to be 1, so we write n squared below it, which is similar to what I did before, but that's just your square numbers. So it's going to be 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And then what we do is actually subtract this line from that line. And as I said, this will work for everyone. So this is your a squared, but we know a is 1. So all I'm left there is bn plus c. 3 minus 1 is 2, 6 minus 4 is 2, 11 minus 9 is 2, 18 minus 1 is 2. Okay, so actually no, bn plus c is actually going to be plus 2. What would normally happen here is you might get a linear sequence and you just do your nth term. So I know bn plus c equals 2. So in this form here, I've got n squared plus 2.